one of the things that's interesting is with the Plugfest, we're learning more about how to have better quality in our drivers and that. And AV drivers have the ability of actually going through logo program so that they can actually get the badge saying they went through WinQual and have been properly tested. How come other filters don't have the same type of quality programs?
That's actually a good question. The real issue is we didn't have the manpower to do it. What we did is we have a set of tests that these filters can go through, and then they wanted specific ones, and they made some very specific tests for antivirus products because they're so important to us because of the security issues and everything. But to do that for all classes of filters was very difficult, and they looked at doing some generic stuff and decided it was just not manpower feasible.
Because at DevCon they were mentioning that they were going to try to do a test rollout, and then it didn't actually come about.
It didn't come about.
Yeah.
They're actually moving to a different model for Longhorn. So any filter will be able to be logoed, but what it'll be is the vendor is certifying that their driver conforms to us. We do have this set of tests called these IFS tests, which basically are a set of tests that do all the file system operations. And if they pass those and their drivers are properly signed, then they can get the logo. So in one sense, they're simplifying it and making it so everyone can get it. But it's just, there's so, as you well know from here, there's so many different kinds of filters. It's very difficult to provide unique tests developed by Microsoft for all of them. It'd be a huge amount of work. And so there's, cost-benefit trade-offs.
Alan, yeah. So we like to also ask questions about the future, be vague, flights of fancy. Is there going to be a managed kernel? Talk to Anders about that. Of course, that's he'd love to see in C#, but yeah. Well, it's obviously there's clearly that's very hypothetical, but there are people in research thinking about those types of things.
Absolutely.
But is there, as we think about the evolution of the OS at the kernel level, are we going to see more abstraction? Because I know we're moving drivers out of kernel mode so that they don't crash the system, but is there going to be sort of like a different type of PAL where we now abstract these types of things away at some point?
It's a very good question, and we've talked about those issues. There was a project internally where they were there's been a couple of different projects, and there are certain classes of drivers that it makes sense to pull out of the kernel and put into user mode, and they're doing that. There was also this project for what they called sandboxing drivers, and it's where you could take a driver designed for the kernel mode and actually run it in user mode, and there's this sandboxing, this sort of interface around it so it couldn't tell that it was up there. But then if he crashed, we could deal with it. That really worked nicely for storage stack device objects because it was much like plug and play, just pulling you can pull your drive out and the system can handle it. And
you haven't gotten one of the new Scribble phones yet.
No, I don't. And so we actually looked at sandboxing for filters. You have to think of it. It's very different what happens at this level of the system versus, where's my pen?
Don't know.
How this actually works is the storage stacks are over here, and they're also stacked. At some point you're down here at some SCSI driver. Let's see, spell it right. This is how the I/O model actually works. There's these file system stacks and these storage stacks, and there's this thing in the middle called a VPB that glues them together. And they had this sandboxing model, and they're moving these things up there. And this thing handles plug and play because it's dealing with hardware, and it can handle the hardware going away and all those things. And they actually had working drivers that work up in the sandboxing model. We took a serious look at doing it for filters, and we may still do something like this. We're still looking down the line. But you have much harder issues. And one of the biggest issues is, if you're talking about a disk driver, you're reading and writing clusters. There's a cache above it, so you're not doing it on every I/O. Well, up here, this is where the cache is. And so if you have things going up to user mode at this level, you're taking, someone's reading a byte at a time. Every one of those I/Os have to go up there. And so the performance impact is a much bigger issue up at this level because you're literally seeing every read and write coming from user mode. Whereas down here, it's all cached and blocked and everything else. And so those are some of the design issues that we have to deal with and still make it performant and all of those issues.
Scalable and reliable.
Exactly. And so we are looking at that thing. One of the things we're looking more at right now is, hopefully all of you have heard about the driver verifier. This is a fantastic piece of technology that they started, I think, in the Windows 2000 timeframe. It's actually built into the I/O manager for the most part, and the kernel. And basically, when you can turn driver verifier on a given driver, and it knows the rules that they're supposed to be following. And if you violate one of these rules, the system bug checks, and then you can see exactly what's wrong and fix it. It's a fabulous feature that they've added. What we want to do is, we have support for a filter verifier for these mini filters, but we want to beef it up a lot. There's a lot more we can do. We have all the infrastructure in place, we have basic stuff. But that's one of the big areas we are looking at, is verification of these mini filters and adding a lot to that. And that'll just make that'll just prove that they're following the rules. And when they violate the rules, like I said this one customer was doing, then we'll catch them and we'll solve those problems back in testing instead of taking a week when it's at a customer's site, those types of things.
So we could almost unit test individual functions that are in the filter then?
Probably yes.
Very cool.
So, yes. So those are the types of things we're looking at. Long term, we still have this idea of the sandboxing and user mode filters and all that stuff. And there may be classes of filters where a user mode component makes sense. And we have to, this all evolves. You know, we have to figure out what makes sense and test it out and things like that.
Sure. Excellent. Now, from a development standpoint, what's your development environment like? I mean, it's up in user mode, we have these great things like, you know, Visual Studio, .NET and whatnot, and it spits out all this code spit for us, and we have great, you know, nice debugging and stuff. Like, what do you use when you write kernel mode code? I mean, you're writing in C. I mean, yeah, when we write in C, well, you purchase the IFS kit, which is basically an enhanced DDK, and it's got all the tools you need to build and compile. And then I use WinDebug, which is an awesome debugging tool that Microsoft actually released for free that allows us to do kernel debugging right in there. So in my case, when I boot up, I actually breakpoint as the OS is starting. I can step through from point A all the way through. For me, it depends. When I'm doing some code, I'll actually use Visual Studio just because it's nice and easy for drag and drop. But most times, I'm a Vi guy because I'm from the Unix world. So a lot of times, I'm just in Vi and running through an actual Unix shell. So I got bash and grep and find and all my normal tools to run through all the code quickly and make the changes. But it's at this level, everyone's got their own flavor. Like I even noticed a lot of Microsoft employees, they all got their own editors that they like, and that's fine, right? It's just whatever's going to do to write C code, and you use what you can, and it's just one of those things.
We do all of these drivers and filters are written either in C or C++.
Okay.
Those are the only languages that are supported. Because Microsoft provides libraries and headers and all of this stuff, and that's all that's supported. And there are a lot of people that write in C++, and that's fine. The filter manager, for example, is written all in C. Okay. And, I mean, internally at Microsoft, all of our build environment is we use whatever editor we want. And it's all, we use basically build, which is a Microsoft tool. It's basically make from a command window. And that's how we make. We don't use Visual Studio or anything like that.
I'm a little lazy, so I actually use NANT. So I actually wrap the actual build scripts that come from Microsoft and then put it in a NANT environment so I can build my user mode code, like my .NET framework stuff, at the same time that I build my driver. So in a single pass, I can do everything. Build Joule and software, what are the top 10 rules that you need to be doing? Are you running out of 10? Well, NANT was the tool for me that allowed me to do that. So, there's MS Build is going to be an actually much nicer way of handling that when that comes. So,
yeah. And Microsoft has an awesome source code control system called Source Depot that's fabulous. What's that?
Perforce on steroids.
That is correct. And so management of all this is actually very simple.
And just for people who might not understand the differences, why would you use C++ versus C? I mean, when you say this is all in C, is it because performance reasons, the libraries? What's the reason?
Personal preference.
Personal preference. That's it.
That's it.
Only a difference between C and C++.
Yeah.
Okay.
The compilers are really good. They generate good optimized code. At at this point, it's really personal preference.
Fantastic.
How did you get into this world?
Now that's a very interesting question. When I graduated from college, and I graduated from BYU, I started working for this, actually before I graduated, I started working for this little company called YCAT Systems. And they wanted to make an OS, and this will date me, this is before there were PCs. And we built hardware, they built hardware on a Motorola 68000 when the chip first came out. They needed an operating system, and I started working on an operating system, and we wrote over 10 years that I was at the company, wrote a very nice, very Unix style, multi-threading, multitasking operating system, wrote a file system and all of these things. I eventually left there and went to work for Novell, and worked at Novell for 5 or 6 years, and helped design and implement a new 64-bit journal file system for them. And when I decided it was time to leave there, I contacted Microsoft, and I had all this file system experience, so I ended up in the file systems group, and they were just starting this filter manager project. And they were pondering that we need to do this, so that's how I got started. But I've written a couple file systems. I've been doing kernel mode development work for over 20 years. I love it.
Would you recommend a college kid get into it today?
Oh, absolutely. You have to think differently, though. There's, I have met developers that are great software engineers, but can't do the kernel mode stuff very well. Because you have to think about the fact that all this code is reentrant. It's all multiprocessor. You have to design everything to realize that there's going to be multiple processors and multiple threads all executing it concurrently. You have to be able to debug it, figure out what's going wrong. And I guess I'm lucky because it's a talent I'm good at.
Well, yeah, I live up in the user mode myself, so I take it for granted.
You take it for
But
granted.
you still have to think about threading. You still have to think about concurrency. You still have to. But
Absolutely.
It's a whole different level. You're thinking context switching and all of that kind of stuff, which we
Yes.
take for granted.
Yes. And there's, different levels of there's types of interrupts that occur in the system and how IOs process. There's actually software interrupts that occur to process the IOs, and you get, based on what level you're at, there's rules on what you can do, and you have to follow these rules, which are all part of the NT IO model. And it takes time to learn. The first week I was at Microsoft, we had one of these plug fests, and I came to it, and people would ask me a question, I had no clue what they were talking about. But you work with this every day, you start writing the software and you learn it, and now I'm one of the experts in this area, and it's just a matter of experience and taking the time to work at it.
Since you dig around in a world that most of us don't dig around in, what's the coolest thing about Windows?
In the kernel mode.
What's the coolest thing about Windows? That's a
What did you say?
Nothing.
What did you say?
The filter manager.
You have a future in marketing.
Actually, what's really nice is just the model that they have for NT and kernel mode is really nice, because there's a kernel up in here, and the IO manager is actually part of this kernel, and there's a lot of support and library routines that are available in there, and so we don't have to worry about hardware, any of those types of differences. That's all very transparent to filter managers. We don't care what processor. It does matter if it's like 64-bit, like the new, Itaniums or the new AMD 64s or Intel 64s. That is a difference that you have to deal with in your code. But the whole environment is very nice. They have a HAL, which is a hardware abstraction layer. It handles a lot of this stuff transparently, the different hardware issues. And so that's very nice. And just the support, the debugging support is fabulous for dealing with this stuff. WinBag is an excellent tool that they've vastly been improved over the last 5 years. Has full source level debugging that finally worked because it didn't.
Windows for a change.
Yes, and I think, and I'll tell you, one of the other cool things is just some of the people you deal with. Interacting with people like Dave Cutler and And
He won't give us an interview, brother. If you can pressure him, we'd love.
And he's one of the guys who invented the NT kernel, right?
Oh, yes.
So people will know.
Actually, it's very interesting. I, years and years ago, did a project on VAX VMS and had to deal with their I/O model for it. And I see a lot of that I/O model in what I see here. And that's because Dave covered it. And, but NT is very well designed. It is very flexible. It's very powerful. It was really designed well from the beginning. And it's a very nice environment to work with. I worked on NetWare for 5 years. Yeah. It is the difference is like between night and day. And so I was working on the NetWare kernel, and trying to add a new file system to the NetWare kernel was very difficult. And doing that type of stuff here is very simple. And so the whole driver model and architecture and how they organize things is actually very well laid out.
If you were drinking tonight with Dave Cutler, and what would you slap his head about? What were you thinking? Is there something that you would like to know what he's done?
When they designed the I/O model, this is one of my things that I think they really did wrong. And I haven't told him this, so if you're watching, Dave, you can come and abuse me. Was that when they designed this stacked I/O model, they made it a call-through model. And what they did is, the I/O manager calls the top guy in the stack, and then it's his job to call the next guy, and it's his job to call the next guy. And there's a lot of issues with that. And that's why we can't unload a filter, and that's why we can't add one in the middle, is because these pointers are actually not even maintained by the kernel. And so they made it so it's all private data. And so one of the things we did is change it to a callback model. I can understand why they did it that way, and it was fine at the time, but they didn't have the foresight of the way the environment was going to be today. And so that part of it, I wish were done differently. But then I wouldn't be having fun doing all this for a couple of years and getting all this implemented. So, and I give people the benefit of the doubt. It's hard to see that far into the future. And I'm sure there's design decisions that we have made in the filter manager that 10 years from now will seem stupid.
NT was designed, 15 years ago. So what was there 15 years ago and what's going to be in 15 years from now, no one can guess.
Yeah,
true.
I'm going to have that HP Superdome in my garage.
Yeah.
Or actually, it's going to be on my cell phone if the trends will be correct, right?
Yeah, it's too bad I don't have this picture.
I was walking around the Computer History Museum in Silicon Valley and counting up the RAM and they have a sizable museum there. I have more RAM on my cell phone than exists in the entire Computer History Museum.
I believe that.
Yeah.
And that is amazing. Yeah. I have a picture that a friend sent me. It was from, I don't remember the company, but it was a picture in 1959 of what a home computer would look like. Yeah. And it was a wall about that size right there. Yeah. And they were talking about how the technology to even do this didn't exist. But that was their, big dials and stuff, and that was their estimate of what a home computer would look like, sometime in the future. Yeah. It was very fun. Things have changed dramatically. I remember, again, this will date me. I remember working on 10 megabyte hard drive, 5¼ inch hard drives. This company, YCAT, when we developed our OS, when we first shipped it, the hard drives were 10 megabytes in size. And now we have hard drives today that are 400 gigabytes in size. And the size of that is dramatic. That just gives you a very simple idea how things have changed in basically 20 years. It's amazing.
Well, thanks for anything else?
Well, just one thing when we talked about design decisions of NT and Unix for that matter, the macro kernel model, right?
Yes.
There are, as hardware evolves, CPUs get huge, et cetera, do you think there will be a time where that model will no longer be the model and will move to the micro model where everything is basically managed, or you have the abstraction layer everywhere?
That's a good question. I could see where we move to that. The hardware is going to just get faster, and so you can do those types of things. In one sense, if you think about what we're doing with the virtual terminal, those are like OSs on top of they're sort of like the kernel and then subkernels on top. And so in one sense, that's what that is. And who knows, maybe they'll figure out how maybe everything is in a virtual machine. And so there is a microkernel at the bottom and nothing but these virtual machines actually running above it, running whatever. I don't know what those plans are because I haven't really talked to those guys.
Purely hypothetical.
Purely hypothetical, but
That's fun.
But I could see, something like that. There's a lot of people here thinking about lots of crazy stuff.
And another question to keep on in this hypothetical land. Do you think the CLR will ever come down here somewhere? I know it's
Charles really loves the CLR.
well, I mean, I understand why at this point in time it's completely unreasonable to think that that's possible, but it would be interesting to be able to write managed code at this level.
I
guess.
actually believe that at some point, yes, it will. I believe that, and don't ask me when that is, I could see it being 10 years from now.
Mm-hmm.
I believe that having the CLR in the kernel will make a lot of sense. And that'll just be another step of making drivers more reliable and more robust. I think we need to, the technology needs to be improved from where it is today. And I don't think anyone would disagree with me on that. But I have actually talked to the device driver guys, the guys that deal with, the different device drivers. Mm-hmm. And they are very seriously talking about how to get that done at some time not that far in the future.
Fantastic.
And so there are people in the company having those discussions.
Sure. Great. Well, thank you very much.
Oh, you're welcome. It was very enjoyable.